Okay. So let's say that you have P naught equal to $1,000, and somebody's giving you a pretty good rate, 6%, which is 0.06. Okay?
Okay.
Now, there's a connection that I usually go to in detail, but we're not going to have time, and I want to give you a picture, okay?
Okay.
But the result of that is this formula, and if we just use this formula, and let's say n equals 12, you're compounding monthly, okay?
Okay.
So you compound monthly. Then P of t is going to equal, just by this formula, which you should totally understand, but which unfortunately gets taught as something you just memorize in a pre-calculus class, which is ridiculous. Still, it's ridiculous, but if that's the way your class is taught and the way your book is written, if that's the way your book is written, it's probably the way your class is taught,
Right, yeah.
then we got to live with it, okay?
Okay.
So, $1,000 multiplied by the rate, which is 0.06, divided by n, which is 12, raised to the nt power, which is the 12t power.
Okay.
Okay? Now we can simplify that a little. Now 0.06 divided by 12 is 0.005, and 1 plus 0.005 is 1.005. Just do the arithmetic, simplify what's in there. And that's raised to the 12t. Okay? Now what you really want to know is, well, how long it's going to take before, I don't know, how much you want this to grow to?
6%?
How much?
6%?
Now, how much money do you want to have? Obviously, you know, a couple $1 billion, but reasonable. Let's say you're investing this because you want it to grow to some certain amount.
Okay.
Okay? Maybe it's $1,500, maybe it's $5,000, maybe it's $50,000. We might not live that long, but you can see. Okay?
Okay.
So how much do you want it to grow to?
1,500.
1,500? Okay. So, okay?
Okay.
Now, we have to use the inverse relationship between an exponential function. See, this is an exponential function. This is a b to the t. Well, it's a b to the 12t, but it's still an exponential function, right?
Mm-hmm.
With base, you could have the base be 1.005 to the 12th and raise that to the t power, because that laws of exponents do that. We'll do that. Okay? Anyhow, this is an exponential function. We have to know how to change exponential equations to logarithmic equations.
Okay.
Okay? So there's a couple of rules. They're simple rules, but you got to apply them carefully. Okay? So I'm going to write the rules down here. Just deciding what okay, if you have b to the x equals c, it's the same as log base b of c equals x. It's because the log function just switches the x and the y.
Okay.
Okay? Matter of fact, maybe I ought to write it this way. Maybe I ought to use a y instead of c. B to the x equals y means that log base b of y equals x. And you see that we've simply switched where the x and the y are. And we switched then from the exponential to the logarithmic function, which happens just when we switch x and y. Now, it's a hand-waving explanation. You haven't processed it. But you can kind of understand that seems kind of similar maybe to the way we drew those graphs and switched the columns, okay?
Okay, yeah.
And I think your book will probably go to some explanation. So what I'm going to do is I'm going to do a little bit of algebra up here, okay? So we have to solve the equation. Well, you want your P of T to be $1,500, right?
Right.
So we're going to set $1,500 equal to this expression. We're going to try to solve for T. So it's $1,500 times, now I'm going to do this. And I don't know why I wrote that down without writing down the rest of it, except that I'm not paying enough attention or something. So let me fix it. I didn't write the rest of the equation, okay? I just skipped right to this expression, which is the next thing I wanted to talk about, but I hadn't gotten there yet, so I shouldn't have done that. Okay, so we write the equation, $1,500 equals $1,000 multiplied by 1.005 to the 12t, right? Instead of 1.005 to the 12t, I'm going to write it like I did, 1.005 to the 12th raised to the t power, because you know from your laws of exponents that you're pretty good with, that 1.005 to the 12th to the t is 1.005 to the 12t, right?
Right.
Okay? Well, is this in the form b to the x equals y? Well, this is like a b to the x, but it's t instead of x, right?
Right.
It's a number raised to a power. Number itself is a power, but we could throw that into a calculator and just get a number if we wanted to. Okay, I'm not going to do that. But the point is, we just need b to the x on one side. So if we had just this on one side of the equation, we'd be able to do this. Okay? Well, how could I get this? Why isn't this in the form b to something equals something else?
Because you have the 1,000.
Because you got the 1,000. So how do we get rid of that?
Subtract it or multiply
No, you
it
can't
together?
subtract it.
Multiply it together.
Multiply what by what?
1,000 times 1.005 to the 12.
No, I can't do that because 1.05005 to the 12th is raised to the t power.
Okay.
Divide by 1,000.
Right.
You know
Yeah.
that.
Yeah, I know.
Look on your face tells me, yeah, you know that perfectly well.
Yeah.
So I'm going to say, and of course I mean divide both sides by that, and we're going to get $1.5. 1,500 divided by 1,000 is 1.5.
Okay.
Okay? Now again, don't make mistakes like you just tried to make.
Yeah.
I mean, it's in class, booming, buzz, and confusion, but you want to be straight on these laws, then why you can't subtract that, because I still see that. And we shouldn't be seeing that in a pre-calculus class, but I see it in my class all the time.
Uh-huh.
It's not a surprising mistake, but please try not to make it. Okay, so anyhow, we have this, right? Okay, well, that is in the form b to the x equals y. So switching it around, b is what? it's 1.005 to the 12th, right?
Right.
And of course, instead of x, we have t, right? But it's, b is this, for sure. That's the base of your exponential expression. Well, where does that go? It goes log base b, right? So we're going to get log base 1.005 to the 12th, whatever that is, okay? Equals of what? Got to be of y, right?
Right.
Well, what's y?
1.5?
Yeah. So all we have to do to apply these is be careful about identifying what's b, what's x, and what's y. Okay?
Okay.
And this equals t. So right there's how long it takes.
Okay.
Okay? And you can take your calculator and figure this out really easily now. Okay? Because the rule that I wrote earlier that you won't remember unless you got a really great memory, and maybe you do, okay? That means t equals the log of 1.5 divided by the log of 1.005 to the 12th. And those are things that you can get on your calculator.
Okay.
Okay? Now just go to your calculator, do 1.005 to the 12th, whatever that is, then hit the log. That'll tell you what the log is, okay?
Okay.
Or maybe the notation of your calculator says you put the log in first and then this, and use the parentheses carefully. But you get this number, and then you put in 1.5 or take the log of 1.5 using your calculator and divide, and that'll tell you how long.
Okay.
Okay? And I guess, let's see, around 6% doubling time would be around 12 years, so you probably hit 1,500 somewhere around the 7th year. Okay?
Okay.
So I'm guessing that if you put this into your calculator correctly, get something in the order of 7. Okay?